focusing in on polynomials. In order to talk about polynomials, first thing we should talk about is what is a monomial. A monomial is made up of numbers and or variables. That are getting multiplied together. We've been dealing with monomials quite a bit in this class. Polynomials are actually one of the most common things that we deal with in an Algebra 2 class. Monomials being a simplified form of a polynomial, or a simpler, I should say, not simplified, are things like -5, or maybe it's 1/2 x, or maybe it's a y, or -4x squared, or x y to the 8th. These are all monomials. They've got numbers, sometimes. They've got variables, sometimes. They're being multiplied together. You're never going to see division, addition, subtraction, negative exponents, roots, like square roots type of thing. You're never going to see dividing by a variable. None of that will show up in a monomial. That's important because getting into polynomials, that's our focus of this entire section, which polynomials is either a monomial or the sum of monomials. So if I take all of these different monomials and I just add them all together, still, that's a polynomial, or individually they're polynomials. There are key things that polynomials cannot have, and if they have them, they're not technically a polynomial. Radicals on variables. Radicals are roots, like square roots. If I have a square root of a variable, a square root of x, automatically not a polynomial. Square root of a number would be perfectly fine, because the square root of a number is just a number. Square root of a variable changes the function family. Oops, just meant to do this. You can't have variables and denominators. Again, the moment you have the variable in the bottom of a fraction, all of a sudden it's no longer a polynomial. The other key thing that you're never going to see is negative, or in general, non-whole exponents on variables. So if you see something like 5x to the power of -6, that negative exponent causes issues. Or 3x to the power of 1/2, that 1/2 in the exponent causes issues. today, one of the things we're going to be looking at is it a polynomial? If not, explain what makes it not a polynomial. I don't need you to explain if it is. If it is, it's just fitting the definition. If it's not, tell me where the issue is. Three x. Polynomial? Do y'all agree with Matt? Yes. Six x squared plus 2x minus 3. Yeah, that is a polynomial. It's just a bunch of monomials added together. It's a bunch of terms made up of variables and numbers getting multiplied. But then they were added together. Do you notice that this looks kind of like the things we were dealing with last chapter? This is a quadratic polynomial. Quadratic expressions are polynomials. Is this a polynomial? Heard one yeah.
Yes. Yeah.
It's just a bunch of numbers getting multiplied by variables and then getting added to other things that are the same.
No.
No? What's the problem? It's got a radical. That cube root of 3 causes issues.
Is that any root?
Any root. Sorry, let me rephrase. Any root on a variable.
Yeah, but
If this was a regular number, it'd be fine. If the y was a number, it'd be okay. Nate's instincts were yeah. I see a radical.
yes.
Raises red flags, but what's the radical on?
15.
15, a regular number. Square root of 15 is just a number. A number in front of x is a number getting multiplied by x. That's perfectly okay. No, why not? No negative exponents. So that 5x to the negative first power is an issue. Okay, last one we're doing like this, and then we're changing things up.
No.
Kieran knows. Why? Can't divide by x, because if you divide by x, that's like putting x in the denominator. Can't have variables in the denominator. Now, to go with our recognizing if it is a polynomial, another thing we're going to be looking at is the degree of it. We're going to start with the degree of a monomial. A monomial degree is the sum of the exponents on the variables. So if I have the term 5x squared, the degree of that would be, well, I look for my variables. There's only one, right? What's the exponent on it?
2.
2. Since there's only one variable, the degree is that exponent. If I had something like negative 7x squared y, degree of this, I look for all my variables. How many variables I got this time?
2.
2. So I got to look at all their exponents. What's the exponent on the x? 2. What's the exponent on the y?
1.
Add them together.
3.
3. This is also a monomial, just the number 9. How many variables that got?
1. 0.
Doesn't currently have any variables on it. What would its degree be?
0.
0. Has to do with the fact that technically I can write 9 as a coefficient of x to the 0th power. Because what's anything to the power of 0?
0.
Oh, 1. So this is all of a sudden 9 times 1. Would you agree with me that 9 is 9 times 1?
Yes.
So I could have written it that way, which would have made the degree 0. Constants are always of degree, 0. Don't mind me, I almost wrote 1. Now, that's the degree if it's a single monomial. If it's a polynomial, you do not look at every single term. Or more accurately, you don't add up the exponents on every single term. You add up the exponents on individual terms, on the individual monomials that make it up. And the polynomial's degree is the largest degree of its individual monomials. We're going to do some examples of that here in a minute. There's one more term I want to talk about first, and then that'll lead to our examples that we're getting to. Because going hand in hand with degree is what's known as the leading coefficient. Do y'all remember what a coefficient is? If I look at the monomials that I had written down not too long ago, the leading, or the coefficient of x squared would have been 5. The coefficient of x squared y would have been -7. What's a coefficient?
The number in front of the x.
The number in front of the variables. The leading coefficient is the number in front of the term with the highest degree. Now you might be wondering to yourself, why does that make it a leading coefficient? Why is leading the word they used? Because leading sounds like it's in front. And the reason they do that is because when you write out a polynomial in standard form, generally you want the biggest degree going first, and then you decrease in degree as you go. That's why when we worked with our quadratic equations, we always wanted them in the form of ax squared plus bx plus c. Because this term's degree 2, this term's degree 1, this term's degree 0. It was decreasing in terms, or in degrees. So some problems today are going to start with ID if it's a polynomial, similar to what we already did. But then they are going to say, if so. Rewrite in standard form. State the degree and leading coefficient. Seven minus 1.6x squared minus 5x. First off, is it a polynomial?
Yes.
Yes. Doesn't have dividing by a variable, doesn't have any roots on variables, doesn't have any negative or fractional exponents. So, is a polynomial. Standard form. Which term would we generally want to have first on this? Negative 1.6x squared. What would generally go next? Negative 5x. And last? Plus 7. So that's standard form. What's the degree? Three. Look at individual terms. What's the degree of this term? 2. What's the degree of this term? What's the degree of this term? Which number is the biggest, 2, 1, or 0?
2.
That's the degree of the polynomial. You look at individual terms, find out their degrees, and you state whichever one's the highest. That is the degree of the overall polynomial. It's of degree 2. Yes? Exponent. Technically, if there's multiple variables, you add up the exponents on that term, but if it's just a single variable equation, all of these are x, it's just the exponents. Leading coefficient. This was the term that had the highest degree. What's its coefficient?
Negative 1.6.
That's the leading coefficient. If you put it in standard form, it should also always be the first coefficient. Same set of instructions, I'm out of room. Start off with, is it a polynomial?
No.
No, why not? Negative exponent. And if it's not a polynomial, you do not need to write it in standard form. You do not need to tell me its degree or its leading coefficient. You simply move on. X cubed plus 6x minus 3x to the fourth. Is it a polynomial? Yes. What would its standard form be? Negative 3x to the fourth plus x cubed plus 6x. Degree?
4.
4. Because if I look at the individual terms, this one's degree is 4, this one's degree is 3, this one's degree is 1. Of those, the biggest one is 4. Leading coefficient. What was that? Negative 3. Is it a polynomial?
Yep.
Yes. It's already in standard form. What's its degree? 3. What's its leading coefficient? 7. One more like this and we're changing it up. Is it a polynomial?
Yep.
You mean that square root's not causing issues?
No.
No, because it's on a number. What's standard form?
It already is in standard form.
It already is in standard form. It's already decreasing in degree. Speaking of which, what is its degree?
1.
1. This term's degree is 1, this term's degree is 0, 1 is bigger. Leading coefficient? The square root of 3. Remember, the coefficient does not have a variable on it. The coefficient's just the number in front. Okay. Got a couple of quick things to talk about yet. The next one being common polynomial types. We've talked about different types of polynomials before. We just never referenced them by their degree or necessarily their type. Some of them we have referenced by their type. And with each of these, I'm going to give you an example of them. Polynomial of degree 0 is one of the most common ones, but it's also one that we don't actually talk about as a polynomial very often. Because a polynomial of degree 0 looks something like f of x is equal to 7. We've talked about what equations that look like this are before. Remember, f of x is a fancy way of saying y. Y equal to a number? Do you remember?
Constant.
It's a constant. It's a constant polynomial. Degree 1 would be like f of x is equal to 2x plus 3. We've talked about this family of functions before too.
Linear.
Linear. Degree 2 we've also talked about. Like 5x squared minus 7x plus 3. Quadratic. Do you know what it's called if it's a polynomial with a degree of 3?
Exponential.
Nope. Exponential has a variable in the exponent. Cubic. Degree of 4. Here's where people tend to stop knowing the names. Cubic is kind of a iffy one if people get it. Quartic. And we could keep going. For the most part, you're only going to see up to the power of 4. But we could keep going. Quintic, then there's hectic, then there's septic, then there's octic, then there's none. I can never say 9. We're just going to stop there. But Generally, you're only going to see up to like 4. They might ask you what type of function it is. So if I were to go back here to this one here that was of degree 4 and leading coefficient 3, if I asked you the type, what type would it be? Quartic. Because it's a polynomial of degree 4. If I were to do that on this one, it would be cubic because it's of degree 3. If I were to have done it on this one, linear. So we could ask that information as well. There's one other thing you're going to see today. This last thing you've seen many times before. Evaluate the following at the given value of x. And then they'll do something like this. F of x is equal to negative x cubed plus 3x squared plus 9. And then they'll tell you x is equal to negative 4. What do they want you to do?
Plug in negative 4 for x.
Plug in negative 4 for x. The first x, the second x, or both x's?
All of them.
Do I need to plug it in here?
No.
Technically, no. When I plug it in, I need to make sure I put it in parentheses. And guess what? You just put it into your calculator then. Go on. Y'all got calculators. I don't know what the number is. I haven't done it yet.
121.
Anyone else get 121? Why is no one plugging into a calculator? And by no one, I mean most people. There are a couple people. You should have a calculator out.
Too poor for that.
If only I provided calculators. Oh wait, I do.
121. That's
121?
Like standing up and walking about.
Notationally, it is f of negative 4 equals 121. Keep in mind they might also show you something like this. And they'll do this instead. It's the same thing. I am plugging in negative 2. Make sure when you plug stuff in, it goes in parentheses, and that your exponents that were on the variables are outside those parentheses. But you're doing the same thing if they give you this notation or if they give you this notation. And the final answer should technically be, oops, that should be a G. In function notation, G of negative 2.
Negative 138.
Sure. I don't know that for a fact. We're going to go with it. Do y'all think you can plug stuff in and tell me what type and the leading coefficient and all that stuff? Today's stuff's pretty straightforward. By the way, couple things to know about this chapter. First off, we've got a number of mini quizzes this chapter. So like tomorrow, we've got a mini quiz as well as a lesson. Also, this chapter we broke in half, which means our first test, which marks the due date for the homework assignments, well, not the due date, the final day I'll take the homework assignments. Our first test is like the middle of next week. Stay on top of things. You easily could get today's assignment done if you're using your time.